number of total resources must remain constant. If a device breaks, let's say you have 2 SSD drive, and then 1 SSD drive breaks, so the algo won't work on this type. It doesn't have a foolproof or fault tolerance. We call it a fault tolerance.
When I did schooling, I was just thanks for 2 months.
Yes.
Yeah, okay. Right. So I think today we will continue with the next tutorial question, tutorial 5 on memory, short-term memory and working memory. So for today, we will start with team 9, 10, 11, followed by 9, 10, 11, 12, and then only we will go with 7 and 8. Okay, is that arrangement okay? Team 9, are you guys there?
Yes, doctor, can you hear me?
Yeah, I can. All right, do you want to start? Okay, you can start.
Good afternoon, doctor. And I'm group 9 and I'm gonna to present the tutorial group 5. Tutorial 5, question 7. So
it's very confusing, I know. All right, go on. I think you're muted.
So our question is, we want to perform a short comedy sketch of scenario or situation that describe the components of the working memory and describe the function of each component and how that relates to your sketch. So first we need to know what are the components in working memory. There are 3 components in the working memory, which are phonological loop, visual spatial sketch page, and the finally is central executive system. So we go to the first one, phonological loop. What is phonological loop? It is a temporary store of mainly verbal information together with a rehearsal mechanism. The phonological loop can have both speech input or audio and non-speech, which are written words then convert into audio. When we hear something, it enters the phonological loop as a trace which fades within 2 seconds unless we refresh it through rehearsal. So what are the functions of phonological loop? It holds verbal and auditory information. It helps us learn language and expand our vocabulary and understand conversation, and lastly remember someone's person name. So now I will give a situation. I want you all to try to memorize the numbers, but not in this form. I want you guys to remember in bahasa. So about 5 minutes and you try to refresh it. Then the second task, I want you to remember this number in English. So after you try which task is easier, task 2, right? So it shows that memory for list of words is better for short words than for long words in our phonological loop. So the second one is Visual Spatial Sketchpad. What is Visual Spatial Sketchpad? It is an important element in the function of working memory. It is responsible for storing and processing information in visual or spatial form, as well as the location or speed of objects in space. So the function is provide a virtual environment for physical simulation, calculation, visualization, and optical memory recall. It is temporarily storing information on how things look, for example, shapes and colors. And it also wants what allows us to manipulate images in our mind. So imagine we want to draw something like flowers. So how we draw? We use our Visual Spatial Sketchpad to hold on a picture of a flower in our mind while trying to reproduce it onto a paper. However, an interesting note is that images from our Visual Spatial Sketchpad fade quickly. While creating a drawing of the flower, we must either keep referring back to the actual flower or continue to retrieve an image of a flower from our long-term memory. The third one is Central Executive System. What is Central Executive System? It is a conductor that coordinates the information provided by the two subsystems, the phonological loop and the Visual Spatial Sketchpad. It is an attentional controlling system, and while the subsystems are more passive, the central executive is dynamic in that it engages in information manipulations. So, what are the functions of central executive system? It is help us to focus attention, divide attention between two concurrent tasks, switch attention from one task to another, and provide a link between working memory and long-term memory. So the next I'm gonna show the example in the last function, which is provide a link between working memory and long-term memory. So same as the first task, I want you to try to remember the numbers I show you. So let's start. Then after you see all the numbers, you try to refresh it. So is it easy? Then I now give you another try, but this time we using a number pad. So which one is easier? I think the task 2 is easier, right? Because visual spatial information from long-term memory, which in this case is the keypad, would blind with short-term verbal memory to boost the performance. Long-term memory facilitates encoding and retrieval when it is combined with the verbal memory trace in the working memory. So that's all from me. Thank you.
Thank you very much, Glenn. Is it Sichun? So yeah, so you guys have actually demonstrated the difference in terms of remembering tasks, auditory tasks, and also visual spatial tasks, right? So, and of course, I think I like the second part where you make the comparison between just the remembering part of some series of numbers individually and trying to remember that on based on this what is it, the number pad, right, that you normally see on your keyboard or calculator. So that is a very obvious example to demonstrate our ability when it comes to trying to separate this visual information and also auditory information that is very much needed especially when we learn, because you're not overloading your working memory, because the working memory itself is very small in capacity in terms of its storage compared to a long-term memory. So therefore, we need to help our working memory, so that, you know, if we can separate what is visual and what is auditory, that is absolutely the best. But I think that is already being shown as part of the example presented by Group 9. So thank you, Group 9, for that. Okay, so let us move on to Team 10. Okay, you can start.
Hey, good afternoon, Doctor and my fellow friends. Today, me and Afiq will be presenting about phonological loops for Group 10. So the question is, the phonological loop is divided into two components. What are they and how are these components beneficial to assist phonological loop with its main function? So support your justification with tasks in the slide, lecture slide that represent these components. Okay, phonological loop or articulatory loop as a whole deals with sound or phonological information. So it is divided into two. One is phonological store and the second one is articulatory rehearsal component. So phonological store is any auditory verbal information is assumed to enter automatically into the phonological store. If it is visually presented, language can be transformed into phonological code by silent articulation and thereby be encoded into the phonological store. Basically, the phonological store acts as an inner ear, remembering speech sounds in their temporal order. So the second one is articulatory rehearsal component. It is sometimes called the articulatory loop that can revive memory traces. The articulatory process acts as an inner voice, repeats the series of words or other speech elements on a loop to prevent them from decaying. So this is the picture of the loop. So the speech inputs will go into the phonological short-term store, and then it will be rehearsed and repeating so it will not decay. Okay, next I'll pass to Afiq.
Okay, good. Thank you, Emir. Good afternoon to Dr. and to my fellow friends. So I will present 3 effects that will eventually affect our phonological loop. So the first one is phonological similatory effect, which is when we're memorizing something like a word or image, something like that, and the things have same pattern. So as example, cat, mat, pet, cap, and lab. These words have the common pronunciation, which is the sound of A, cat, mat, something like that. So the second task is the specific word which is doesn't have any common pronunciation, which is bar, kid, son, and toe. So this is actually will affect the phonological loop whenever it will enter the phonological store, which is short-term memory. So because of the similarity effect, it will affect our brain to make a confusion. So it will kind of hard to remember the words. Emir, you stop presenting.
Stop presenting.
Yeah, I cannot see your screen. Okay, so for the second task, which is bar, kid, son, and toe, this has no common pronunciation, so it actually easier for us to remember the words. Okay, next. The second effect is word length effect, which is the longer the word is, the harder our brain to remember, which is will affect our phonological loop. So let's see the task 1. My very easy method, just pick up names, which is a shorter words, and if you need to memorize this, it will easier for you instead of the second task, which is Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, which is a longer words. So this will hard to make to memorize it. And actually, this is the example for an acronym to memorize some terms, which is Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. We can make an acronym. My very easy method, just pick up names, which is make us to easy to remember this solar system planets. Okay, next, the last effect is articulatory suppression. What is articulatory suppression? Articulatory suppression is the process of inhibiting memory performance by speaking while being presented with an item to remember. So let's say you are speaking, and at the same time you need to remember something. So for the first task, you just need to remember school, university, college, villa, apartment, and that is actually easier than the second task, which is every single word need to be compiled with staying at. Let's say staying at home, staying at hotel, staying office. So the word staying at is actually inhibiting our memory performance. So it will make our brains harder to memorize these words. So these are the effect that affect the phonological loop. So that's all from us. Thank you.
Thanks very much, team. Which team number is this? Team 9? Team 10?
Team 10.
Yep. So yeah, so you guys have given examples of the two components of phonological loop. What are they again?
Phonological store and articulatory rehearsal component.
Absolutely. So when an information actually gets into well, actually reaches our working memory, right? Without us knowing, that piece of information actually gets repeated. So that's why you have this place where you actually repeat the information even without you repeating it yourself. Okay, so of course that will eventually give an implication to the effect that we will later have, the ones that have been described by your friend, which is basically phonological similarity effect. Okay, and the word length effect. So anything that is long enough cannot be retained in this storage, in this working memory, because of our limited storage. It's small enough, so anything that is long, then you don't have time, your memory itself don't have time to repeat and to actually get it stored in the next storage, or to actually retrieve it from the working memory for further processing. And another one is articulatory suppression. So if you have any words that is well, unnecessary, which eventually makes the word long enough, then again also the same effect happens, where our ability to remember the longer words is basically reduced, simply because of this word length effect that we have looked into, because there was very limited opportunity to do rehearsal. Okay, so yeah, well done, team 10, for coming up with a different version of the stimulus. So yeah, I appreciate that. Thank you. Okay. So let's move on to the next group, or team 11. I think you're muted.
Yeah. Good afternoon, madam, and all my classmates. Can you see my screen?
Yes.
Okay. So I'm Chiang from Group 11. So today we are going to present the Visual Spatial Sketchpad. So our question is to carry out an experiment with at least 6 participants to show the human's Visual Spatial Sketchpad. So first of all, let us define what is the Visual Spatial Sketchpad. It is a memory used to do the visual representations. It allows us to visualize something and keep it in our mind eyes. And we use these skills to do maths and remember how's the patterns and image and a sequence of events. So the visual sketchpad enables us to visualize and do the spatial informations. Visual information refers to what the things look like. It's likely that the visual spatial sketchpad plays an important role in helping us to keep track of where we are and in the relations of the objects as we move along the environment, so that we will not collide with the objects around us. So this is how how we visualize something. So first of all, our visual cortex will encode the size of the coffee cup, and then the MTL, which is which we call the medial temporal lobe, will bind the widespread cortical memory trace of the coffee cup and its semantic associations. And then we will in our mind will have a visual cortex decode the MTL based neurocortical memory bundles and reconstruct the coffee cups. So as we draw along the coffee cup, our visual cortex will decode our MTL memories. So these are our brains, and then the visual spatial sketchpad is located behind our brain. Then this is the experiment that we did it. So I think we can have an interaction, like we all can later we all can you all can look at the image for 50 seconds, memorize it, and then draw what you remember after 15 seconds has ended. So let's start it. So let's see, you all can see through all the characteristics and the details of the image and then try to memorize it in your brain. Okay, I think the 15 seconds ended. So you all can try to visualize in your brain and how's the what's the object inside in the past scenes, like the image that I shown just now. You all can start memorizing, start refreshing, and recall back the thing that you all saw. So in our experiment, we try to carry out this experiment to show that our brain we actually can visualize the scenes in our brain, and through the ability of the visual spatial sketchpad. So this is our video, a short videos. Yeah, this is our first participant's result. Then the rest of it, as you can see from all the results that we got, mostly the participants can recognize or remember the object that is very large or get more easily to be observed, like sofa, pillow, table, books, vase, and flowers. So most of the participants managed to draw these easily observable objects out. So as you can see, this is our result. We take in this experiment, there are around 6 people that participate in this experiment. So these are our explanations. The central executive in our working memory monitors and coordinates the visual spatial sketchpad, which decide what information to be attended and processed. Our brain only managed to remember some part of the presented scenes, but couldn't sketch out all the detailed versions of the scenes. Participants end up drawing details that are easily to be observed only, like the sofa, table, books, vase, and etc. Next, we have another experiment or like activities, also related to the visual spatial sketchpad. So first, let's compare the two objects in each picture and present and identify whether they are the same or not. Then we need to ignore the orientation and the color. Okay, let's try this out. You all can identify there are 4 pictures and which have only one picture, one option is wrong. So can you all identify out which option is wrong? Like you all can compare the first image and with the second image. Let's take about around 10 seconds. So this to identify how we analyze how we visualize image in our brain, and to do some geometrical analysis and also orientations. So the answer is C, which is wrong. Then the object are the same, just different orientations and geometries. So these are our explanations. In our mind, we can do a mental rotations, which is a recognitive operation during which a mental image is formed and rotated it into a different oriented in the space. Our brain is capable of visualize the rotations of object mentally, despite the two objects being compared only showing in one position. Such process usually requires cognitive manipulations and spatial transformations of two-dimensional or three-dimensional objects. Yeah, that's all from us. Thank you very much.
Thank you, Chilam, Tan Chilam. So you are basically representing, is it then team 11?
Yes.
Okay, so yeah, so very good example there that you have for Visual Spatial Sketchpad. I think the first example is really interesting, where you show participants a series of images, no, just one image, and then they were supposed to replicate that, right? And they only saw that for 15 seconds. So that also supports our limited capacity of our working memory still, because it's also part of our short-term memory. So information in that space, in that component, doesn't stay for a very long time. Okay, so that's why it's also very interesting to see how much participants are able to remember the information if it's only purely what is it, visual. Had you to replicate this experiment, and if you were to put some kind of audio, right, like maybe some kind of sound or someone describing the scenario, maybe the results would be say slightly different, because then what is it, the working memory has to process two forms or two types of information. One is the image type, another one is the audio type, so it will be very heavy for the central executive. For the later part, also a very good example, but maybe this is more related to is it this week, or if it's not this week, maybe a topic that we will learn in the next few weeks, on mental rotation. So we will again look at how how we can best do this mental rotation. But yes, it is true, we do have some kind of ability to rotate, to be able to kind of like estimate how much rotation we can get from a specific orientation, whether you have it for, let's say, 90 degrees rotation or 45 degrees or 180 degrees. So this is something that we will look at later, but it's good that you guys have looked into this, already given some kind of discussion on how this is related to the Visual Spatial Sketchpad. So yeah, well done, team 11. Okay, all right, okay, now let's move on to team 12.
No, doctor. So can you hear me and see my screen?
All right, go on.
Okay. So again, good afternoon, doctor, and all my fellow classmates. So I will represent Group 12 to present for question 10, which is basically to discuss what experiments or studies that have been used to describe the central executive, and what are the evidences supporting the idea that better comprehension, reasoning, and intelligence are related to having a larger and more efficient working memory. So the first study is actually the dual task methodology, where it states that if a person is able to do tasks simultaneously if they are using different processing systems, for which are shown at the diagram, the two subsystems, phonological loop and the Visual Spatial Sketchpad. In another word, if you are doing two different tasks by using the same subsystem, then it's gonna be hard. For example, if I were to ask you to pat your stomach and rub your head at the same time, some people might find it hard because both tasks employ VSSP. Or another example is that if I ask you to talk with two different people at the same time, you also find it hard because you are receiving two auditory information at the same time, and the load is heavy for your phonological loop to store it. So next one, the next experiment is the multiple errand test. So as we know, the central executive memory is actually to involve in planning and coordinations by making use the information stored in the three subsystems: the phonological loop, the episodic buffer, the VSSP. So here is the test called the Wisconsin card sorting test, which is to evaluate the performance on planning and coordination of central executive. So the Wisconsin card sorting test is actually giving the participant a pile of cards and ask the participant to match the card with the 4 cards given here. This 1, 2, 3, 4 cards. So let's say you have this card and you want to match with this. So you actually have many options. You can actually match it with the numbers of elements, 2 match to 2, or you can match it with the patterns, the same patterns, or match it with the same color. So the participant is not told how he's going to match the cards. So let's say if the participant match this one with this one, and the one giving the test will say, oh, it's not based on the number. Okay, and the one giving the test will say, oh no, it's not, it's a mismatch. Then you know that number is not the criteria to match the cards. So you may match this card with this one, and again the one giving the test will say no, it's a mismatch again. So you know that it should be matched with colors. So throughout the process, you are actually undergoing the planning and coordinations by making use the past experience, because the first time you are matching it with the numbers, the second time you are matching it with the pattern, and last you know it's a color. So throughout the process, the central executive is actually taking part in the planning and coordinations. And for most of us, it's actually easy to do these kinds of matching. But for some people with diexecutive disorder, they may find it hard because they may repeat, making mistake. Maybe they will first they will match this one with this one, and they are told mismatch. They might match this one with this one again, and that's why they cannot do the matching like us, because they have the shows the preservative errors. So the last one is the evidence that support better comprehension, reasoning, and intelligence related to efficient working memory. As we know, the working memory is actually to retrieve the informations and manipulate the informations. So when you have the ability of this, you can actually comprehend and understand the information easier, and also you can draw the inference and conclusions easier. And with the ability to manipulate informations, you actually can solve complex problems too. So they are correlated. If you are able to manipulate more informations, you are able to solve more complex problems. So according to Peter, I don't know how to pronounce the name, Doolittle. Okay, he said that people with good working memory tends to be good storyteller and score in standardized tests. So that's all from us. Thank you.
Awesome. Thank you very much, Chen Yi, representing Team 12. Yeah, so it's interesting how you end your presentation just now with how the implication of having a larger working memory actually saves you, and of course it relates to having in some sense better IQ, because you are able to correlate between these to find a closer relationship between the auditory part and also the visual spatial sketchpad. It's not Scratch, but it's visual spatial sketchpad. Yeah, I know it's very confusing, but yeah, you can check the correct spelling in the notes. Yeah, so very good examples of how this works, and also what you have already shown earlier on also I think correlates with what we have already discussed in the class. So yeah, well then, team 12.
Doctor.
Right.
By the way, sorry, doctor, because I also found some of the sources online where it writes Visual Spatial Sketchpad. So just to clarify, it is a wrong term.
It is Sketchpad, I think. Because in the what is it, textbook, normally it's referred as Sketch. Yeah.
All right, noted. Thank you, doctor.
Right, you're welcome. All right, now let's move on to team 7.
Assalamualaikum. Can you hear my voice, Doctor?
Yes, I can.
Can you see the screen?
Yeah. Can start.
Okay. Okay. Assalamualaikum and good evening to Dr. Neza and everyone. My name is Farhan from T7. Will present tutorial 5, question number 5. Okay. The question is describe a new piece of evidence other than the ones from the lecture notes supporting the following types of coding in short-term memory. Okay, so there are 3 types of coding in STM, which is auditory, visual, and semantic coding. Okay, for the visual coding involves information being stored in the form of image or patterns. Okay, for example, here is brand logo and names. Okay, sometimes we know what the logo is, but we cannot know the name of the logo or the companies or otherwise. Okay, so we also usually we relate what we see with logo that we know. For example, Nike. If we saw anywhere a right tick logo, we will immediately imagine that okay, this thing will relate to Nike. Or when we saw a small letter of M, we will imagine about McDonald's. Okay, so the next is auditory coding. Auditory coding involves information being stored in the form of sound. For example, when we repeatedly hearing a song, or maybe we hear it on radio or TikTok repeatedly, we will automatically remember the song without actually looking at the lyrics. And usually the chorus of the song also is more easier to remember as it is catchy or meaningful. So people can usually remember the chorus of a new song immediately. And last but not least is semantic coding. Semantic coding involves storing information in terms of its meaning. So the example here is mnemonics or acronyms. It's one way to help encode simple material into memory. A mnemonic is any organization techniques that can be used to help remember something. Okay, for example here, we can see a simple mnemonics to memorize the arrangement of planets in our solar system. My very educated mother just serve us noodles, or like the team 10 present just now, my very easy methods just pick up name. Okay, so that's all from me. Thank you.
Thank you very much, Farhan, representing team 7. Is it 7? Yeah, 7. So yeah, so I think I will just highlight a bit about the different types of coding we have in short-term memory. So you've got what was it, Farhan?
Visual brand logo. For auditory, hearing song repeatedly. And for the semantic coding, acronyms.
Exactly. So you have 3 types over there. So you've got visual, you've got also what is it, auditory, right?
Auditory, yes.
And also semantic. Okay, so the visual ones, just like what we saw, like somebody got very, very hungry after seeing the McDonald's what is it, logo, because we have a very close association with what that means, food, right? So yeah, you still have to resist for a few more hours. So you can do it. Just like how you see a Nike, just do it. Yeah, you can definitely do it. So that is basically in terms of visual. Whenever we see some sort of brand, because we're so used to that, so it's got some sort of relation as well as semantic, because just looking at the brand logo without having some kind of previous experience with that specific brand or logo name, then you still wouldn't be able to associate, wouldn't be able to recognize that so quickly. But yeah, so with this visual in relation to the semantic, acronyms, association of acronyms, and then having relating that to some sort of conceptual knowledge, or associating that with some kind of a sentence, right? Like what this team had and the previous team showed. You can come up definitely with so many different association, different meaning to the same acronym, right? Even though by the end of the day, the acronym on its own will still be the same, but you can have different sentences. So that is the power of semantic, which not only assists our short-term memory, but also helps us when it comes to doing chunking. Just like, I cannot remember so many questions already now, but if it's not this group, then it's basically from the other group, group 1. So you guys will also have access to what have been presented in the other group to better understand how they answer the question. So that is basically the importance of semantic and auditory, especially when you listen to a piece of music. Sometimes you can, without even listening from the very beginning, listening maybe somewhere in between or the chorus, you can still follow, right? If it's a song that you like. So this is again an association and understanding of a context based on auditory information that you can relate with your previous experience. So yeah. Thank you very much, Team 7, for that presentation. And now we should go to our final team, Team 8.
Yeah. Can you see my screen?
Yes, I can.
Yeah. Okay. So good afternoon to Doctor and everyone. So I'm from Team 8. And this is my group members, which is Iza, Ham, me, Tam, Go, So, and also Shahil. So we get the question 6, which is discuss and illustrate the difference between the model of memory and the Badar's working memories model, which is better and why. So first, I will explain about the model of memories. So model of memory, also known as the multi-store model, which contains sensory memory, short-term memory, and also the long-term memory. So what is the sensory memory? Sensory memory exists in each of our sense. Besides, it remembers an input in great details, but for only a few milliseconds. For example, when there is a sound, our ears can receive the sound, and the sound will store in our brain for just a millisecond. Yeah. So second is the short-term memory. It also known as the working memory. Information can be stored for 30 seconds without any efforts being made to remember and rehearse it. And for the last one is long-term memory. It is a permanent store of memories which are received from the short-term store, and it holds all the information but are not consciously aware of any given time. So the difference from the short-term memory and long-term memory is that after years or after many years decay, short-term memory will be forgiven, while the long-term memory will still there. We can rehearse it and we can remember it. So what is the model of the memory? Yeah. So for example, here is an input, and our sensory memory will detect it and will attention our short-term memory. So our short-term memory will store it for around 30 seconds. If we want to store it at a long-term memory, we can rehearsal it, or we can rehearsal it, or we always practice it. So if we don't want to make it as a long-term memory, so it will become a short-term memory and will be forgive after a long time. Okay, so what is the better working memory model? Better working memory model is proposed by the Bederer and Heath in 1974. Working memory is a limited capacity system for temporary storage and manipulation of information for complex tasks such as comprehension, learning, and listening. So the main difference is it can perform complex tasks. So what is the better working memory models? Working memory has replaced the short-term memories. So at first, we will have the phonological loop, which like when we hear a sound, the sound will get by the ears and will loop in our brain. Also, visual spatial sketch page, which means that when we see a scene, our eyes can catch it, and this picture will picture in our brain for a time. And last one, and for the episodic buffer, it will control. It will organize, then bring all of our memory to wall pictures. It means in other words, it will organize, then it will analyze, so we can get the answer. For the example, when we get one mathematical question, which is 1 + 1, our ears can receive the sound 1 + 1, and our buffer, our episodic buffer, will use the visual spatial to show 1 + 1 in our brain, and it will refresh to our primary school and get the answer 1 + 1 is equals to 2. Okay, so for the central executive is that it control all the of our visual spatial, episodic, and the phonological loop. So the difference of model of memory and the Bederer working memory is that model of memory will illustrate short-term memory as a single component, while Bederer will illustrate short-term memory as multi-component. Model of memory will hold info for brief period, while Bederer will manipulate info during complex condition. Model of memory will describe the loss of memory through decay, while Bederer does not describe the loss of memory through decay. Model of memory will separate short-term and long-term store without specific structure within short-term memory, while Bederer will become more modular with separate store of phonological loop, visual spatial sketchpad, and the central executive. So when they compare, Bederer working memory will wins. This is because Bederer working memory is an improvement on the original model of memory with evidence. First evidence is the case of KF. KF was in a motorcycle accident in 1970, and his brain is damaged. So the damage is for the STM short-term memory part. So what is the cause is that he can remember the words better if present visually as opposed to auditory. So this shows that they are separate short-term memory component for visual information and verbal information. So the second evidence is supported by dual task study. So this study is to investigate if the participant can use different parts of working memory at the same time. So the method is we give the participant to perform 2 tasks at the same time. First task is digit span task, which require them to repeat a list of numbers. And the second task is verbal listening task, which require them to answer the true or false of various simple questions. Okay, so the result is as the number of digits increase in the digit span task, participants took longer to answer the listening questions, but not much longer, only fraction of a second. And they did not make any more error in the verbal listening task as the number of the digit increase. So the conclusion is the verbal listening task made use of the central executive and the digit span task made use of the phonological loop. That's all from me. Thank you.
Thank you. Is it Tam? Kai Xiong?
Yeah. Yeah.
Right. Okay. Thank you, Tom. So, we have probably looked at a lot initially on the working memory, on the different components of working memory. But in this one, we're actually looking at the difference between the three components of working memory versus the model of memory that we look before we learn about this working memory. So, I think it has been put in a nice way, the difference of these two types of memory models. And of course, over time, we now tend to rely more on this working memory as well, basically to represent our short-term memory. But still, if you look at the fundamental principle, both types of models are still applicable, because you still need to receive some kind of information from your five senses, and then in your short-term memory, then you have then it will go into your short-term memory, and then only you have to do rehearsal and things like that for you to eventually store the information and also to retrieve some past information or past knowledge from your working memory, from your long-term memory. So this is with the initial fundamental model of memory. And then it was described that based on this Baddeley's working memory model, it has been shown that we can perform a lot better if the information gets to be tuned accordingly, according to its modality, whether it is coming from audio or whether it is basically visual information or any kind of spatial information. And absolutely, you have this middle person. The episodic buffer is there to maintain the amount sorry, I think there was a bit of internet issue just now, to maintain the information between these two components, right? So so I think with that we have already completed all our tutorial for this week. Unless if you guys have any questions, then I think we can call it a day for the course for this tutorial. And I will see you guys on Thursday for the lecture. Okay.
Okay, thank you, Doctor.
All right, thank you. Okay then.
Thank you, Doctor.
Thank you, Doctor.
Thanks. See you guys on Thursday. Bye. Assalamualaikum.
Assalam.
Waalaikumsalam.
Doctor, I have one